Welcome to the YouTube channel Command Line. In this video series, we are going to study the book Introduction to Algorithms. This book is written by four authors: Thomas H. Corman, Charles L. Lecherson, Ronald L. Rivest, and Clifford Stein. These people are pioneers in the computing industry. For example, you must be knowing what is RSA. You might have used the RSA key somewhere. So the R in the RSA has come from the name Ronald L. Rivest. He is one of the inventor of RSA key algorithm. This book is first published in 1990. The fourth edition of the book has been published in 2022. So until 2022, in the first 20 years, the book has been sold for 500,000, and when the fourth edition was available in the market, it was sold for another 500,000. So far, totally 1 million physical copies of this book have been sold. By looking at the numbers only, you can understand how significant this book is, how much people are evaluating this book. This book is actually for beginners, but it is not completely beginner friendly. So you should have some understanding of programming. You should know the basic concepts of a program like if conditions, for loop, and how to write a basic program. Those things you should know. And you need to have a strong fundamentals in basic arithmetic. Basic arithmetic like logarithms you should know. You should be able to understand quadratic equations. You should be able to know how to solve a quadratic equation and those things. You don't have to worry about that. So when you read this book in a self-paced manner, you may have to know these prerequisites. But that's where the lectures, the professors are coming into picture. When you are being taught in a college, when you are being taught in a curriculum style, so those gaps will be filled, and we want to add, for example, in this video series, I will be giving you the prerequisite training before that. For example, before you start learning about merge sort, you may have to calculate the complexity in log. So I will explain you what is log and how to calculate log, and those kind of basic fundamental needs which are prerequisite for the book will be covered prior to when you go into those sections. And second thing, you don't need to worry about the size of the book. If you see, the book has more than 1600 pages. But why we need to read that much big book for learning algorithms? We can go to some website and there they will list all the algorithms. There will be sorting algorithm, searching algorithm, binary search, everything will be there. You can just learn the algorithm and then you can be just well versed, and then you can have some hands-on in lead code and other pages. So you will get the idea. Right. But why we have to read this book? First thing is, in the book like this, in this kind of books, they will talk the same topic again and again and again. So you don't need to do the grinding by yourself. Okay, when you read some particular algorithm, they'll keep on talking, they'll talk all the nuances, they will talk that multiple times. So it will keep repeating in your head, it will keep repeating in your memory. So naturally it will start storing in the memory. You don't need to do the grind yourself. The book content itself will do that. And second thing is, in this book, it talks more about why. When you learn an algorithm, or when you are about to choose one particular algorithm over other one, it will tell the reasons. It will tell the reasons to so fundamental levels. You don't need to remember things actually. When you have a question, you can just correlate things one by one, and based on that, you can come to the conclusion. You don't need to memorize, or you don't need to remember things. You can theoretically come to the conclusion one by one. So this is from the preface of the book. Why we have to learn algorithms? You look around your home, you will find algorithms running most mundane places. Your microwave oven, your washing machine, and of course your computer. So the algorithms in our world, they decide when we have to wake up, the alarm in the clock, and what song we have to listen, the playlist, the automatic playlist coming in the YouTube Music or Amazon Music, wherever you are listening, your video playlist, the video suggestion algorithm there, the movie recommendations in your Apple TV. All those things are coming from algorithms only. We may think algorithms are simple, then they are just helping in our day-to-day life. But actually speaking, at places, we are even relying on algorithm for our own life. For example, think of your car's brake system, or think of the medical equipments, for example, MRI scan. So those kind of places, algorithms are so critical, human lives are depending on them. And who should read the book? This book is primarily intended for graduate and undergraduate students. So this book could be used as a textbook for graduate and undergraduate. Technical professionals who is already in the job, who want to improvise their knowledge or who want to prepare for interviews, they should follow this book. So this particular term I liked. When they mentioned about algorithms, they said some algorithms are simple and some are more involved. They didn't use the word complex. It means those algorithms are not actually complex. They just want you to be more involved. They want you to spend more time on that. So when you give more involvement and more time, you will understand that. So simple algorithms will be like, you don't need to involve so much, you'll grasp that just by giving a glance. But for a complex algorithms, you have to be more involved, you have to give more time. So that's what they mention here. As I told you, this book will be used as a textbook for graduate and undergraduate students. This book comes with some book pack questions. So as an exercise, as problem statements are coming there. For all of them, the solution can be found at the link. What you should know before starting reading this book. They are quoting us some programming experience. As I told you, to understand algorithms, you cannot be completely novice. You should have some idea about programming constructs, like the if condition, the for loop. You should be able to write a basic simple program, maybe a simple arithmetic calculator. You should know about recursion, you should know about for loops. So those things are very fundamental here. Second is, you should know little bit of data structures. So data structure is nothing but how we will organize data. So we will learn more about data structures when we start learning the algorithms also. And the other important prerequisite to learn this book is some mathematical constructs. Some elementary level mathematical constructs like logarithms, how to calculate log, and quadratic equations, how to solve x in a quadratic equation, and those things. You don't need to worry about that. In this video series, we will learn the basic constructs before we are getting into the problems. These authors put so much effort to make this book self-contained. Each chapter is self-contained. So you can either choose to read sequentially from the starting to the end. Also, if you want to understand some particular concept or some particular algorithm, you can open the relevant chapter and read that. This is in the first page of the first chapter of this book. Here goes the definition of the algorithm. An algorithm is any well-defined computational procedure that takes some value or set of values as input and produces some value or set of values as output in a finite amount of time. There are two important factors we have to give more consideration here. First one is well-defined. By specifying well-defined means, an algorithm should be very clear. There shouldn't be any room for any ambiguity. For any input, the algorithm should be able to provide the correct answer. Or if the input is irrelevant, the algorithm should be able to determine that and reject that input. And there shouldn't be any corner case, and the algorithm shouldn't go into any unpredictable behaviors based on the input. Otherwise, users can exploit the algorithm. And second thing is, it should compute in finite amount of time. And second thing is, finite amount of time. By finite amount of time means the algorithm should conclude in a certain amount of time. Theoretically, somebody can able to prove an algorithm will solve the problem, but practically it may not able to conclude in any practical finite amount of time. In that case, there is no point considering that algorithm at all. An algorithm for a computational problem is correct if and only if for every problem instance provided as input, the algorithm should compute in a finite amount of time and it should output the correct solution. There can be multiple correct algorithms coexist for a single problem. Similarly, there can be incorrect algorithms, like we have given the characteristics if an algorithm is correct. So it means if any one of them is not getting solved here, then that can be considered as an incorrect algorithm. So why I am talking about incorrect algorithms here? Because there are certain situations where we will use incorrect algorithms, even though they are not going to give us a correct answer, but we will use them to control the errors at some places. So those things we will study in the book in the future chapters. Let's see some real world example where algorithms are crucial. The Human Genome Project. The Human Genome Project tries to map all the pairs in a human DNA. You know the DNA, right? So it is like a ladder in a spiral format. So every steps in the ladder is a one bond. So now scientists want to map the entire genome sequence. So we have more than 3 billion such bonds, such steps in DNA, and we want to identify them and store them. First of all, identifying itself is it's a crucial process here. It is not very easy because DNA is very microscopic level structure. Those bonds of atomic level bonds. There are just 2 or 3 hydrogen atoms between the bonds. So you have to identify how many atoms are there. Based on that, you have to tell whether it is adenine or thymine. So that identification itself will take critical amount of time. And for that, we need critical imaging clustering algorithms, which will actually use the electron microscopic images to identify, okay, this is this kind of bond, and then they have to put that in the database. And second thing is, once we identify and store the entire sequence, the real mammoth problem comes next. Why we have to identify and store the sequence? The fundamental of this project is we can identify some genes which are causing the hereditary issues in human, and we can try to eradicate those genomes, so which will kind of save us from hereditary diseases. Or how people will do that? There is some disease which is hereditary. What scientists will do is they will take the genome sequence of many people having the same hereditary condition. Particularly they should be like not blood relative, and then they will take their sequence, they will compare them, they will try to identify what is the common sequence in their genome. By identifying the common sequence, you may try to they will try to conclude which particular genome sequence is causing that particular genetic condition. So once you identify that, you can able to remove that particular genome using some viruses called bacteriophages and fill that with some good genome in that place. So the subsequent generation will not have that disease. This is the idea. So to map all the people's genome, you need to have good algorithms. Once you map like 3 billion amount of bonds in a database, now you need to do comparison. So you have multiple genome sequences from multiple people. Now you have to put them in a comparison. So it has to come and tell what are the common sequences in those people's genome. So to have a database of 3 billion entries and multiple DBs like that, and you have to do cluster mapping for those DB, you need a very good algorithm in that case. So once they identify that sequence, they have to remove that. So to remove that, there are millions of bacteriopages, and they have to identify which bacteriopage will actually go and remove that particular sequence. So that is again a searching algorithm comes into picture. So these are the crucial areas where algorithms are playing critical role. So by seeing this amount of scale, if you make like 1% improvement in these algorithms, it can easily save some thousands of people's life. Yeah, next is internet. Internet packet routing is one critical thing. Like the packet should be routed to a less traffic area, because the internet is completely connected with wires. So underground cables are going everywhere. They have to identify which network is less congested, and they have to route the traffic. One practical example or one connecting example I can tell you is the recent Netflix live streaming of the boxing match was not successful because there was too many glitches. The real problem was the stream was not properly routed. A better algorithm would have easily solved the problem. For example, you take Hotstar or Jio Cinemas, they are streaming IPL to crores of people without any glitches. So this is the difference of algorithm working in practical internet. Then electronic commerce. So you must be using some e-commerce like Flipkart or Amazon or Alibaba, whatever, so and so. So that makes our life very easier, right? But the problem here is we are uploading our credit card information, we are giving our banking details to all these e-commerce websites every now and then. Without a very tight or secure algorithms, those data is at risk. What if the data is not properly encrypted and the encrypt is weak? Easily people can able to decrypt the data and see your banking information, and they can use that, right? So algorithm plays a crucial role here, saving your personal data and your money as well. Manufacturing and other commercial enterprises often need to allocate scarce resource in a modest beneficial way. For example, an oil company has to determine which particular places they have to dig well. So oil companies will usually make very tiny deep holes. They will make some explosions. Based on the resonance, they will identify where the oil patches are. So the oil patches will be clusters of distributed clusters in the geographical area. Now they have to determine what are the places they can able to dig well. So one well should able to be replenished by the multiple reservoirs. So they will have a map of oil reservoirs. Now they have to determine what are the places where if they dig well over there, they can take more amount of oil. Another example they mentioned here is a marketing campaign. They mentioned it as a political marketing campaign, but it doesn't need to be just political. It can be for any product marketing as well. So you have multiple billboards, and each billboard costs certain amount of rupees. So you have only a certain amount of money for allocating for the marketing. In that case, you have to identify what are the billboards and how many people you can able to reach from those billboards and how much they cost, and based on that, with the amount of money you have for marketing budget, you should able to reach most of the people, right? Most possible people using the existing billboards. So these are the places people use algorithms. Then this is a very typical problem. So you have a map of a city. So there are multiple interjunctions. So you have the map which is saying like from intersection A to intersection B, this is the distance, and B to C is the distance, and C to D. So the entire city map is with you. So now the problem is you have to reach certain intersections, and you have to identify the most optimal path. Think of an example of Amazon delivery. On a particular day, they have to deliver to 50 locations. They have to identify optimal road. Now they have to identify the optimal route to reach all the 50 locations with less fuel efficiency. A human cannot optimally think of it every day, every morning based on all the 50 addresses. So the best way here is algorithms are doing this job. Here is a practical example of a topological sort. For example, you are a car manufacturing company, and for manufacturing a car, you need like 10 products, and for the 10 products, there are like each 10 product is having like 10 spares. So now you have to identify, some spares will be shared across some products also. So to make these 10 products, first of all, those 10 spares should be available. So once those 10 spares are available, then the product will be ready. Once these 10 products are ready, then you can make the car out of that. So now you have to identify which product should come to the floor first and which product should be manufactured first. Based on that only you have to make the order to the supplier. Based on that you have to design your supply chain, you have to floor modeling. So these kind of things are done by algorithms. Algorithms are playing critical role in medical field also. For example, there's a set of MRI images or ultrasonic images. Now the doctor has to determine whether the lesion is a trivial growth or it is some cancer tumor. So how the doctor will determine that? He should have studied in his past experience. He should have seen multiple scan reports like that, and based on that he can able to determine whether some particular image is related to a cancer cell or not. So the same kind of things we have to feed to a algorithm, and the algorithm will take multiple previous images and then it will do clustering. It will run clustering algorithm, and then it can able to determine whether a particular image is related to a cancer tumor or a normal cell. So after reading all these things, we should start considering algorithm as technology. Why so? Technology in the sense we will see like in a software industry or in a computing industry, yeah, fast hardware is better, right? Or a fast GUI technology which will make the life easier. So you can able to touch and then you can able to give input faster. So similarly, by selecting the right algorithm, you make the product better. So we have seen the e-commerce problem, right? Every morning they have to identify the shortest route to deliver all the 50 places. So you add a better algorithm which will find the path faster, or which will find a better path every time. So in that case you can save the fuel, you can save your time, you can save cost. At the same time you can be environment friendly also. So algorithm similar to other technology is making the life much better. The recent problem if you are seeing, now the AI is a buzzword, right? All the companies are spending too much on AI. But where the majority of the cost goes? The majority of the cost for AI goes for energy. If you see, even Google today has tied up nuclear power plant manufacturing company. So Google is going behind nuclear power for powering the data centers. Why AI takes so much power? The algorithms which run those AI technology, which is learning the pattern, which is learning the interference, and those algorithms are running for like very long time and they need more power. So you optimize those algorithms, find a better algorithm which will run for shorter amount of time, consume lesser power. It will actually save lots of energy. That will even reduce the carbon footprint of the entire world. So here is a simple example to show the difference of algorithm. For choosing the right algorithm, how much difference it will give. Let's take a problem of we have to sort 10 million integers and we have a computer which will run 10 billion instructions per second. So typically computers currently are not 10 billion instructions per second, they are running somewhere around 3 to 4 billion instructions per second. Let's say we have a faster computer which will run 10 billion instructions per second. Now the problem here is we just need to sort 10 million integers using this particular computer. You may think 10 million is so big, but not really. The number of searches happening in the internet per minute is more than 10 million. If you run insertion sort for these 10 million numbers, that program will run for 20 minutes. Instead of insertion sort, you take merge sort. That sorting will happen in just 1.16 seconds. So see the difference. It is like almost 20 times. Even if you buy a better computer which will run 20 billion instructions per second, it will only reduce the amount by 50% only. But here it is like 2000%, like 20 times the improvement just by selecting the right algorithm. You don't need to buy any new hardware. You don't need to work on any great technologies. So algorithm itself is acting as a technology here. So here is another controversy. So they even mentioned that in the book. So you may think now AI is taking over. AI is evolving better. And you are thinking like AI is taking over jobs of many people. So when AI is taking over, why you need to learn algorithms? AI itself will learn algorithm, it will write the code on itself. So AI will develop algorithms itself. Why people need to learn algorithm? It is not true. The reverse is true. Why? Because to develop better AI, you need better algorithms. As I told you now, the current AI technology is taking so much amount of energy, and because of that it is very slow, and you cannot able to create models very quickly. To create one full model, a big company like Google is taking like 6 months to 8 months. Improve the algorithm little bit, like 50%, it will reduce the timeline from 8 months to 4 months. So it is not like because of AI you don't need to learn algorithm. It is actually because of AI you have to learn more algorithm. That's what the authors are trying to say here. This is just an introductory video, so we didn't learn any algorithms here. We just learned why it is important, why we should learn algorithms, and what are the places algorithms are playing a very crucial role. You might not even realize, okay, you are using algorithms at this place, but now you would have thought, from now onwards, whenever you see something happens, something which is very normal like a traffic signal, try to identify what kind of algorithms can run behind that. So try to see how an algorithm can improve this particular problem. Let's see in the next video soon. Thank you for watching.